Alright guys, so let's work through a couple of these homework problems from section 11.1. Now, number 41 from the text is a little bit different than some of the other ones because now we've got this sort of like function where we've got x's involved, but the thing that's approaching 0 is not the x, it's this other letter that appears here, this other variable h. Okay. So we're going to sort of approach it the same way, except what we're looking for now is what happens when we get h really close to 0, not x. Okay. Now the usual sort of shortcut of just trying to plug it in doesn't work right away, right? Because the h in the denominator won't allow us to plug 0 in, right? Okay, so what we want to do is maybe expand, simplify, see what happens when we start moving things around and see if maybe we can get it to the point that we could just plug 0 in for h. So the only option we really have is to take this term, this x plus h squared, and square it out and see what we get, right? So if we do that, we've got the limit as h goes to 0, right? So when we square that out, we'll get x squared plus 2xh plus h squared, and then we've got the minus x squared left over, and we're dividing all this by h. Okay, now this gives us what we want, right? Because the x squared here and the minus x squared over here are going to cancel each other out. And so what we end up with is, again, the limit as h goes to 0, and now on top we just have 2xh plus h squared. On the bottom we've got h. There's an h conveniently, right, in each of these two terms, so we can factor that out and then cancel, right? So when you factor it out, you'll get 2x plus h, and this is all over h, right? So when you do something like this, just double check for yourself. I mean, if I multiply this h through here, do I get what I had up here? I do, so that means we did it correctly. Now we can cancel these two h's out, and we're left simply with the limit as h goes to 0 of 2x plus h. Now, at this point, when you're writing things like this down, I would definitely encourage you to put parentheses here, okay? Just because if they're not there, it's not really clear. Are you saying the limit of 2x or the limit of 2x plus h? Okay, this makes it really clear as to what you're saying. So once you've done that, right, this thing is sort of just like a polynomial now, right? So it's easy enough to just plug 0 in for h. Okay, so we've got this 2x, we've got plus 0, right? So when you do that arithmetic, it's pretty easy, right? You just end up with 2x. So this is our limit. Okay. One of the other things I just want to add now at the end is when you're doing problems like this, definitely at each stage rewrite this limit thing. I know it's a little bit tedious, but it helps just to keep track of it so you don't at some point forget that you've got the limit there. It's just a good habit to get into. Next, all right, let's take a look at number 45. Now this is a limit as x is going to infinity, right, or specifically in this case negative infinity. Okay, so we've got the limit as x goes to negative infinity of 3x squared plus 2x all divided by 2x squared minus 2x plus 1. Okay, so the technique that we use for these types of problems is that we divide everything by the highest power of x that we see. Okay, so in this case, the highest power of x that we have is 2, right? So we've got x squared. So we're just going to divide everything through by x squared and see what we're left with. Okay, so we've got the limit as x goes to negative infinity. So we've got 3x squared over x squared plus 2x over x squared, and this is all divided by 2x squared over x squared minus 2x over x squared plus 1 over x squared. Okay, well, let's see what happens when we cancel some of this stuff and simplify a little bit. Right, this term up here is just going to become 3. This term is going to become 2 divided by x. Right, this term here is going to become a 2, right? The x squareds cancel. Here we get 1x canceling, so we've got 2 over x. And here there's nothing canceling, so we've got 1 over x squared. And so now what you're doing is you're just taking the limits of pretty much each of these things individually and seeing what you end up with, right? So the limit of 3, well, 3 is just a number, right? So that's just going to be 3. The limit of 2 over x as x goes to negative infinity is 0, right? As x gets bigger and bigger, 2 over x gets closer and closer to 0. Right? The limit of 2 is just 2. The limit of negative 2 over x is just 0. The limit of 1 over x squared is just 0. So when all is said and done, what we're left with is 3 over 2. All right, so that's our limit there. Now, 47 is a similar type of problem. It's a little bit. There are a few more terms to take into consideration, but this is the limit as x goes to infinity. So now we've got 3x cubed plus 2x minus 1 all over 2x to the fourth minus 3x cubed minus 2. All right, so in this case, we're looking for the x term with the highest power, right? So that's going to be x to the fourth in this case, right? So what we're going to do is we're going to take each term and divide it by x to the fourth. Okay. And once you've done a few of these, you should be able to do it more quickly, but I'll kind of work through the whole thing here. So here we've got 3x cubed over x to the fourth. Here we've got 2x over x to the fourth. Here we've got 1 over x to the fourth. And then in the denominator, we've got 2x to the fourth over x to the fourth, 3x cubed over x to the fourth, and 2 over x to the fourth. Okay, so now again, just sort of see what cancels and see what you're left with. All right, well, up here we've got 3 over x, 2 over x cubed, and 1 over negative x to the fourth. And in the denominator we get 2, we get 3 over x, and we get 2 over x to the fourth. Okay, so now we're sort of applying the limit to each of these terms, right? You just kind of distribute it through the top and the bottom. So when you take the limit of this first guy, you're just going to get 0, right? The limit as x goes to infinity of 3 over x is 0. Same for this term, right? The limit of 2 over x cubed as x goes to infinity is also 0. And the same thing holds true here. So we've got 0 plus 0 minus 0. Now in the denominator, we've got 2 minus 0 minus 0. So what we're left with is 0 over 2, which is just 0. So that's our limit. Now the thing to remember is that this type of thing only works, right, because the denominator is not 0, right? So if we were to end up with a 0 in the denominator, we'd have a different type of issue to work with. All right.